Okay, men, we're jumping over to chapter 3 now in our new textbook. We're going to talk about object-oriented programming and methods. We've been using objects for a while. For example, look at a glabel. We've thrown a few of those on the screen. A glabel itself is an object, and then we give it a different name. In the past, we've been using myObject. The right-hand side of the equation tells us that we want to set aside a little memory for our new object. And we've also been using a lot of methods so far. In our new applets, we've been using some public void run. And you can always tell when you have a method on your hands because of the parentheses. And usually, except in the case of the main method, the name of the method is usually sort of a verb, some sort of action, such as set color, get x, set filled. These are all some methods we've seen in the past. And there's a bunch of methods that all the objects we've used so far have in common, such as we've been able to get x, get y, move, set location. And the reason is because of all the objects we've used, such as rectangle, oval, label, they all have
Andrew Kent, please call extension 8000. Andrew Kent, 8000.
They all have a parent that they inherit a lot of things from, which is a larger G object class, as you can see at the top of this graphic. So just like you might inherit things from your parents, such as the color of your eyes or hair, something like that, all of these objects inherit things as well. Another way of looking at that, instead of saying it's the parent-child relationship, you could call this the superclass, and these could be called the subclasses. So, and as it says down here, the code for particular objects, those are often left to the specific classes. So you can think of it in a way as like the way our federal government versus state government works. Maybe some of the larger items that are shared among all the states are set at the federal level, which would be our G object, and then these various ones can implement their own laws or their own methods and things of that nature. Such as in the G rectangle, we wouldn't use the set font method. That's only going to be used with the G label. So some are specific only to the various classes and others to the superclass. Now, we also see the keyword extends on our new program, on the ACM programs, and what that refers to is the abstract class that we're inheriting. Just like graphics program means it's going to be a graphical applet as opposed to the console program that we can extend. It means that we're inheriting something from an abstract class, which in our minds, it's an oversimplification, but we could say that it's something that we don't get to see the contents of. All right, now we also, getting back to methods, methods are just groups of a group of code that's bunched together and given a name so that we can reference all those lines of code just by one quick, easy name. So they take a large, as the slide says, a large programming job, and they can cut it up into bite-sized tasks. Now, one thing to keep in mind, in the class examples, it's not always the most efficient way to do it, to set things up like we'll do in some future programs. But much larger like enterprise level professional programs, they have to break things up into more manageable sizes. Otherwise, it would just be unwieldy and you'd have millions of lines in one file. So not only do methods allow us to pull things into separate areas, but eventually when we get into objects, we can even put some of those lines of code in separate files. So as I said earlier, a method is usually an activity, and it's used to deal with code complexity. And one of the advantages is once we've created it, we can use it over and over and over again. Just like every time we click on a mouse, there's not separate code for that executes that mouse click. They're just calling upon the same code over and over and over again. So it comes in, it really helps us be lazy in the long run. All right, so let's code this example. Notice this one is a console program. And what we're going to do, we're going to have our main run method that we've been using for our with these ACM graphics. It's going to print this message jumping to display hello method, and then we're going to do what's called a method call, display hello with the parentheses and a semicolon. And what this line means, it calls this method down here to execute. Now notice our run method ends right here. In the past, we've kind of been setting things up where we're all inside of our main method. Now we can create our own separate methods. So we're going to declare this one, public void, display hello. This is our method definition. And then here are the contents. So when we call upon display hello to execute, What it means is it's going to execute this line or whatever lines we put in there. All right, let's take a closer look at that method. As you can see from this bubble right here, this is the method header. That just declares the name of the method. And this is the method body. Once again, when we call upon the method, this is what executes. So if the method's not going to do anything, display hello does not execute at all until we call upon it. So it will sit there doing nothing. Just like the mouse click, if you don't press that button, nothing happens. So it's waiting for something to happen. And to do that, we need a method call. And we can use that over and over and over. All right, so the first exercise based on that program that you coded, create a second method called display goodbye, and then have that method do the following: print goodbye. And then, of course, you're going to have to call upon that from within your run method.